All right, this video is on the features of exponential and logarithmic functions. We have already learned how to graph both of these functions. Now we are going to analyze the certain characteristics of each of the functions' graphs. So in class, what I did was I created a chart for you guys to fill out all of these features. So if you go ahead and print that out, you can be filling out that chart as we go along. So for the first row, number 1, the equation was y equals 2 log base 3 of x plus 8. So go ahead and write that down in your function equation column. We are going to first look for the asymptote of this equation, and then we're going to plot that on our graph. So let's go to that. To find the asymptote of a logarithm function, we first need to remember that logarithms are always going to have vertical asymptotes, okay? So I'm going to remind us here that logarithms have vertical asymptotes. I like to remind students a way to remember is if you look at the word log and you see the L for log, you can use that as a reminder that it has to be a vertical asymptote, an up and down line. So vertical asymptote for log is found by taking the expression after the log and set it equal to 0. So we're going to take x plus 8 and set it equal to 0. And with that, we know that x has to equal negative 8. So I'm going to go and plot the x equals negative 8 line. So here's our x equals negative 8 line, okay? So our graph does not pass that line. It gets really close to it, infinitely close, but it never does touch or cross that x equals 8 line. So let's go ahead and label that. Okay, so that's the next thing you will fill out in your column. Then we are asked to determine whether our graph is increasing or if it's decreasing. Well, whenever you guys do increase or decrease when it comes to our graphs, you need to always make sure that you read your graphs from left to right, okay? Always read your graphs from left to right and analyze what is going on with the y values, okay? You are focusing on the y values. Are the y values going up or going down? So if you trace your graph, okay, and I'm going to trace it right now from left to right. If I trace my graph from left to right, I notice that my graph is continuously increasing, okay? It's continuously increasing. So the y values are going up here. They are going up. The y values are still going up consistently, okay? They get higher and higher and higher. So in this case, our y values are going to increase, okay? So write INC in the chart. Next, you are going to be required to find the domain and range of our graph. The domain are always the x values of our graph. What x values are being used to graph the curve that you are seeing right now? So if you look at the x-axis, okay, so if we focus solely on the x-axis, because we're looking at what of this portion here, what is being used to plot our curve? Well, one thing we notice is that we are not going to use the entire x-axis. This right here is never going to be used because our graph is completely on the right-hand side of our x equals negative 8. It's completely on this side, right? So the only part of the x-axis that we're going to use is this. This is the only part that we're going to end up using, okay? So what are we going to do to explain all of that we just said? Okay, so how do we explain that we're not using the left part of x equals negative 8 and only everything to the right? Well, what you're going to do is, let me go here, is tell me I want you to go from -8 all the way, sorry, that's not -8, -8 all the way to positive infinity. Okay, because what you're telling me is I am only using the x values that are to the right of -8. And I cannot use anything other than parentheses on -8 because I don't want to include that number. Let's talk about the range values. The range values, on the other hand, have to do with the y values. The y values are, if we're focusing now, is the vertical axis. What portion of the vertical axis are we using? Well, if you notice, this graph goes infinitely down and is infinitely increasing. There are no gaps or breaks in this graph. It's a smooth, continuous curve. We notice that we're using the entire y-axis. Therefore, we're going to go from -infinity to positive infinity, which is the same thing as saying all real numbers, okay? But the interval notation is -infinity to positive infinity. Something I do want to draw your attention to is that you will always start with the smaller value, okay? So when it comes to domain, you always read the graph from left to right. When it comes to range, you always read it from bottom to top, okay? So I'm going to make a note here to remind you. For domain, you always go left to right, L to R. Range, you always go from bottom to top, okay? Because the bottom numbers here, bottom, are smaller than the top numbers, okay? That's why you always go from small to bigger numbers. Okay. So those are the next two columns that were covered for domain and range. The last thing we are going to do is the end behavior of y equals 2 log base 3 of x plus 8. End behavior has to do with the ends of our graph. So specifically what we're talking about in this particular graph is we want to know what's going on with the behavior of this side and on this side. So this is going to be known as my left end. So let me write it down like this. Yikes. Let's do this again. This is the left end of my graph. And this is going to be the right end of my graph. Now I need you to explain to me what is going on at both of those ends, okay? So you're going to use a certain script to describe it. So the first thing you need to do is always tell me which arrow you're looking at and then what is happening to the y values of those ends. End behavior is interested in knowing, are your y values rising or your y values falling? So just looking at this right now, I can tell that my left end here is definitely falling. You know, this end falls. And this end over here is definitely rising, okay? So I know that's happening. But I need a little bit more detail in our mathematical script, okay? Since we've been reading our graph from left to right consistently, I'm going to start with the left, okay? So when you're giving me the end behavior of each one of these ends, you are kind of giving me an estimated x and y coordinate of a moving target, okay? So what do I mean by that? So here's what I mean. So right now, I can find a point right here on this end, couldn't I? There's a point. But this point is also going to be another one right here. And there's going to be another one right here. Okay, so do you see where I'm going with this? This end keeps going and going and going infinitely. So if you were to give me the x and y on each one of these points, it'd get pretty tedious, okay? But what I'm asking you is to tell me, well, what kind of behavior are you seeing at that left end? So in order to describe that behavior, I need you to give me what's happening at the x and what's happening at the y, okay? Well, on each one of those values that I just plotted, those black dots, what is the x looking like at the first dot and at the second dot? So what I'm talking about is, what is the x value for this one? What was the x value for this and for this and for this consistently? What were those x values? Well, each one of those x values looks like to have an x value of -8 every single time. Notice that these points get closer and closer to the x equals -8 asymptote, but never really touch it, but I can say it gets close enough to x equals -8. So I'm going to write, as x approaches -8, comma, what is happening to my y values? Well, let's look at the y values. Well, the y values keep changing for sure. The first one looked like it had a y value of -10. The next one was close to -11, -12. It keeps dropping. So the y values keep becoming negative. They don't get close to any one particular y value. They keep changing. They keep getting more and more negative every single time. So what I need you to know is that this symbol right here that you see right there, you read that symbol as the word approaches. So the way you would read this statement is, as x approaches -8, the y values approach -infinity. So what you just finished doing is pretty much giving me some sort of xy coordinate description of what's happening on that end. You're telling me all those dots pretty much were -8, and all of them are going to have negative y values, okay? -infinity. Let's do it the same thing again for the other end, okay? So I'm going to write, as x approaches, I'm going to leave a space here. I'm going to put something there, comma, y is going to approach something, okay? So let's figure out what's going on. Look at the right-hand side. Again, if you need the description of what I was talking about before, we have a point right here. We have another point right here and another one right here. And we just can keep going, right? All these points are just going to happen every single time. Well, what do we know about the x value? Well, notice that the x value was first like close to around 9, then it was 10, and then it was like 9.9, and then it was a 10.5 or 11.5. It just keeps going. The x keep changing every single time, right? But one thing we do know is that they always stay positive. How about the y? The y value also. The y value kept changing. It kept going up, 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 up. You can be picky about it, 5, 5.1, 5.2, 5.3. But what would we know? It kept changing, but it always stayed positive. That's how you write your end behavior. Okay, you're describing what is happening at those points. So let's try number 2. So that's how you do a logarithm 1. Let's go to number 2. The goal is I'm going to do the first 2 with you, and you do the next 4 on your own. So number 2 is y equals 2 times 1/3 to the x power. Now we know this is an exponential function, and what we know from the previous section is that exponential functions will always have what? Horizontal asymptotes. Okay. Horizontal asymptotes for exponential functions. Okay. Exponential. Exponential. Goodness gracious, functions. Keep pressing that button. Are dependent on, horizontal asymptotes are dependent on the vertical translation of your exponential functions. So let's put a reminder here, vertical translation. Now, if you look at our function, there's no constant being added or subtracted to 2 to the 1/3 x. So for our problem, our y asymptote is going to be y equals 0. Okay, so let's draw that asymptote. So if we look here, here's our y equals 0 asymptote. our green graph from left to right gets really close to y equals 0, but again, approaches infinitely close, but doesn't ever cross it. So the first thing they asked us was to find that and graph it, so that's what you do. And then you are going to tell me if it's increasing or decreasing from left to right. What is happening to the y values? Are they increasing or are they decreasing? Well, from left to right, we look at it, we trace it, okay? And we notice that it's just going down, 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 and it just keeps flattening out eventually. But our graph is decreasing. It gets closer and closer to that y equals 0 line because it's getting closer. It's going down and down, so it's consistently decreasing the entire time. So for this one, we can easily say it's decreasing, okay? Let's go to domain. Domain are our x values. What are happening to the x values of this graph? Well, if you look at the x-axis says that, not the x-axis says, the graph says that it's going to go to the far left and to the far right forever. And because it's doing that, it means that it's using all the negatives and all the positive x's to be able to graph it. Can the same thing be said about the range values? Well, our asymptote helps us here as well, because notice that the asymptote said, hey, the graph is being graphed everywhere upwards from the y equals 0. Down here, nothing is happening, okay? This side, there is no green graph happening. So what are our range values? Are we using the entire y-axis? We are not going to end up using the entire y-axis. The only part of the y-axis we're going to end up using has to be above the y equals 0 line. So how do we say that? Well, we say all the numbers above y equals 0 have to be from 0 upwards. Because remember, you always have to start with the smaller number. Remember, I told you guys go from bottom to top, from left to right, okay? Bottom to top, left to right. So from 0 to infinity, you are going to say is the range. Notice that the 0 of the asymptote went into the range. Going back to our previous problem, the -8, goodness gracious, the -8 up here in pink from our asymptote went right here with our domain. If it's x equals -8, x is domain values. That's why it goes over here in domain. Going back to the problem we are on, y equals 0's range values, that's why you put it over here with the range. Okay? All right, next. We are going to do end behavior. So let's look at the ends. Let's look at this end first, our left. So what is happening at our left end behavior right here? So if I make up points to help me visualize it, I'm looking at, like this point right here, looking at this point right here. What is the x value of each one of these points that I'm graphing? Okay, well, I notice that the x keeps getting negative. Every point goes more and more to the left. So I'm going to say, as x approaches negative infinity, what is going to happen to my y values? Well, I notice that my y values keep going more and more up. Every single one of these dots, the y value went up, the y value went up. So I'm just going to say that, okay? So each one of the x's got more and more negative. Each one of the y values got more and more positive, okay? Let's do it for the next one. Well, since I already see the pattern of how my end behavior is written, I'm just going to go ahead and write this. As x approaches, I'm going to leave a blank, comma, y is going to approach, I'm going to leave a blank. So in my blank spots, I just put what the x is and what the y is. So let's look on the other end. The other end, we were looking at this one, okay? So what do the x values there look like? What's happening there? Well, our x's, if we do the little plotting again, let's plot. Here's an x value, here's an x value, here's an x value, an x value, an x value. Notice I'm graphing it on the green line, right? Well, what's happening to each one of those x values as I'm graphing it? Well, every single one of those x values keep getting more and more positive. So I'm going to put positive infinity. What's happening to each one of those y values? Well, each one of those y values, they pretty much are not going anywhere. They're staying there. They're not going up or more down or anything like that. They're just staying at y equals 0. And then that's my end behavior for the last part of the columns. Okay? So what I need you to do is pause the video and see what you would do for the next 2 problems. I want you to do number 3 and number 4. Okay? And then come visit and tell me what you did. Pause the video now. Okay, students, so here we are. So you would have graphed a horizontal asymptote at y equals 6 because the vertical translation is plus 6. It's the constant plus 6 that's adding to the negative 2x plus 6. So that's where we got this from right here. We look at our graph, and as we read our graph from left to right, we notice that our numbers are constantly going down. As far as your domain goes, well, we can kind of look at here at our horizontal asymptote, and we notice that the only restriction we have is that the y has to not ever equal 6. So for domain, that means it's going to always be all real numbers. But for range, because of the restriction of our asymptote, we notice that our graph will always be below this y equals 6 line, okay? It's always going to be underneath it. And y means range values, right? So what is it that I'm going to write here? Well, if it's everything from below, it has to be from negative infinity all the way to positive 6, because I always have to start from the bottom. So the only place that I can graph in is from negative infinity to 6. So let's look at our end behavior. Our end behavior says to look at the left side. The left side that is getting really, really close to 6, but it's going more and more left. So that means our x values are getting very negative, but very close to 6 always. How about the right? Well, the right is just getting positive and positive and positive. It keeps going to the right. What's happened to our our y values? They keep getting more and more negative and negative and negative and negative every single time. Okay? See if I can make this a little bit closer. It's not allowing me. Gets closer and closer to negative infinity. There we go. Okay, so those are notice that you're just filling, this is end behavior. What is happening to the y values, and then you tell me which end you're looking at by telling me x approaches blank. Okay, let's go to 4th problem. So the 4th problem, our vertical asymptote is at x equals 2. You set the expression after the log equal to 2 and then solve. Sorry, I said that wrong. You set your vertical asymptote x minus 2 equal to 0 and solve, and you get x equals 2 because you added 2 to both sides. Now, increase or decrease? Well, from left to right, the left end of my green, all the way to the right, my pen is increasing as far as the y values are concerned. Let's look at the domain. So vertical asymptote restriction was x equals 2. So we can use any of the domain values that are to the right of 2, okay? Nothing over here. Nothing was allowed on this side. So I need to tell them that my x values start at 2 and they go right. Nothing else is allowed to be used. 2 and to infinity. That's what this 2 to infinity here is. That's what the 2 to infinity symbol here means. Okay, goes to the right to all the positive values. How about our range? Well, there's no restriction in asymptotes for y. The graph goes all the way down and it goes all the way up. So we're using up all the y values. How about the end behavior? Well, let me look for a color here. Our end behavior here, well, notice again, we have a whole bunch of dots we can end up drawing. One there, one there, one here, one here. Notice that all those are very close to 2. So x is approaching 2, but all those numbers are going to go and become more negative. Okay. Yet on the other side, the x's are going to get more positive and they're going to keep going up. More positive and keep going up. All right. Pause your video after you've checked these two, and now I want you to do the last two on your own and then come back to me. Okay, welcome back to checking your answers. Here are our last two problems. All right, so the equation y equals 2 times 2 to the x minus 5 has a vertical translation of y equals negative 5. Of negative 5, therefore giving us a horizontal asymptote of y equals negative 5. So as you see, it's drawn already on our graph. Make sure you do that on your sheet as well. This time, as we examine our graph from left to right, so here's our left-hand side and we trace, we notice that our y values are going to be increasing gradually from left to right, therefore telling us that we are going to increase. Did I say decrease? If I said decrease, I meant increase. Our y values are going to gradually increase. So circle your increase or write it down on your chart as INC for increase. Our asymptote is at y equals negative 5. That's the only restriction we have on this graph. Other than that, our x values are free for all. We can do negative infinity to positive infinity. We don't have any asymptotes preventing us from going left and right, but as far as range going up and down, notice that we are only allowed to be above this graph. Down here, not so much. So bottom to top, that means we started at negative 5 and all the way above. That's the only place we can graph our exponential function. Focusing on what is going on at our ends. Well, here at our left end, what are happening to the x values? Well, the x values are continuously getting very negative. So I'm going to say, well, they keep changing and they become more and more negative. But as far as their y values, they're getting awfully close to that asymptote of y equals negative 5. They never get there, but they get pretty close to there. So, whoops, I didn't mean to do that. Chose the wrong one. So right now, I'll write over this again so you can see it better. Y equals negative infinity. X equals negative infinity. Our graph keeps getting more and more negative to the left, but the points get closer and closer to negative 5. They never touch the negative 5 axis of symmetry, but they get close enough. Remember, those ends are in constant movement in whatever direction, okay? They're not stagnant, all right? All right, the other end over here, the right-hand side, what do we notice about those x's and those y values? Well, it's going to the right forever. It's also going up forever. Has two movements. So let's go ahead and say that. Let me highlight my answers here. So we are going to say it continuously goes to the right for x, and it continuously goes up for the y. So you're describing what is happening at those ends. Okay. Last but not least, y equals -2 log base 2 of x minus 1. For logarithms, you take the expression that comes right after your logarithm. A lot of students make the careless mistake, or no, it's not even careless. They make the assumption that x minus 1 goes together because they're visualizing it like this. Let me go back to a previous problem. They're visualizing it like this, right? But you are going to notice on this one, there aren't any parentheses. So you can only set what's after the log function equal to 0. So that gives us the vertical purple asymptote that I've drawn there for x equals 0. We trace our graph from left to right. So from left all the way to the right. And I notice that my y values are consistently decreasing. What's happening to the domain? Well, our asymptote has x's, so it has to do with the domain. And they're telling us, hey, make sure you stay to the right of that asymptote. So I am going to say that the only place I'm allowed to be is from 0 to infinity, 0 to the right. The range is fair game. All the way up, all the way down, no restrictions. So you're going to put all real numbers for your answers on that one. Okay. What's happening in our end behavior? We are filling out these 4 blanks. Remember, that's what you're always filling out. So as x approaches, we're going to do this one first. I always do the left ones first. Okay. What is x approaching? Well, that arrow is getting really, really, really close to that asymptote, and that asymptote is x equals 0. So that's pretty easy. What about the y values? Well, it's going up forever. How about the other one, this end? What's happening to the x values? Well, this arrow is going forever to the right, so it has to be positive infinity. What else? Y values. What's happened to that arrow? Is that arrow going up or is it going down? But right now, based on what we could tell, the arrow is going fully down. Okay, so the positive infinity was for the x going to the right, right? So this was the positive infinity. And now we need to know what is going down mean. That will be negative infinity. And that, my friends, is the note-taking guide for your section 10-2. Okay, so make sure to transpose all these features onto that chart and go to the graphs and make sure you draw out your asymptotes. Thanks for watching.